The question is, a certain vector in the xy plane has an x component of 4 meter, x component 4 meter and y component of 10 meter. It is then rotated in the xy plane so that its x component is doubled, then its new component y is. So in which the x component is 4 meter means x component shows the I unit vector. Therefore, vector r1 is equal to 4I plus y component 10 meter. Y component, y axis is shows by the unit vector j. So therefore, the vector r should write 4I plus 10j. It is then rotated in xy plane so that its x component is doubled. So the next vector r2, x component is double means 2 into 4I plus, so then its new component, we don't know new y component, that is y is the new component, you determine the y. So therefore r2 is equal to 4 2 ja 8I plus yj. Okay, this is the equation. So the modulus of r1 vector is equal to modulus of r2 vector, then you get the y. So modulus, so we know the coefficient squares, r1 coefficient square root of 4 square plus 10 square is equal to, so root of r2 vector, the coefficient is 8 square plus y square. Squaring on both sides, the root gets cancelled. 4 4 ja 16 plus 100 is equal to 64 plus y square. So 100 plus 16, 116, 116. So 64 minus 64 is equal to y square. 116 minus 64 is the 52. So y is equal to root of 52. So therefore root 50, 7.49, 7 point something, 7.2 meter. So this is the answer. Option in second option is the correct one. The question is, sum of magnitudes of two forces acting at a point is 16 Newton. If their resultant is normal to smaller force and has a magnitude 8 Newton, then the forces are, so first option 6 Newton, 10 Newton, second 8 Newton, 8 Newton, third 4 Newton, 12 Newton, fourth option 2 Newton, 14 Newton. So first the sum of magnitude of the two forces. So modulus of F1 plus modulus of F2 is equal to, is given 16. If their resultant, so resultant R is nothing but, suppose F1 plus F2, this resultant is normal or perpendicular to the smaller force, suppose F2 is the smaller force, and is given the R value is 8 newtons. So then the forces are, you calculate F1 and F2 is equal to how much? F1 value and F2 values are measured. So we know the resultant formula, R is equal to under root of F1 square plus F2 square plus 2F1 F2 cos theta. So in which F1 and F2, so R square is equal to F1 square plus F2 square plus 2 F1 F2 cos theta. But the condition resultant R is perpendicular to F2, so means the dot product of the resultant of is f1 plus f2 dot smaller plus f2 is equal to 0. So these are the vector, these are another vector. When these two are perpendicular, its dot product is 0. So sub multiplied f1 into f2, f1 dot f2 plus f2 square is equal to 0. So f1 and f2, f1 dot f2 means f1 f2 cos theta plus f2 square is equal to 0. So f1 f2 cos theta is equal to plus moves outside f2 square. So here in this equation 1, so we have f1 f2 cos theta, therefore r square, equation 1, r square is equal to f1 square plus f2 square plus f1 f2 cos theta is the minus f2, therefore 2 into minus f2 square. Then so r square is equal to f1 square plus f2 square plus into minus minus 2f2 square. R square is equal to f1 square plus f2 square minus 2f2 square. We know r value 8. 8 square is equal to f1 square minus f2 square. Therefore 64 is equal to f1 square minus, so from f1 plus f2 is equal to 16, in which f2 is equal to, I can write 16 minus f1. This value substitute here, therefore 16 minus f whole square. Therefore 64 is equal to f1 square minus of 16 square 256, so plus f square minus 32 f1 f1. So by simplification we get f1 is equal to 10 Newton. The f1 is substitute in this equation, f2 is equal to 16 minus 10, so f2 is equal to 6 newtons. So f1 10 Newton, f2 6 Newton. The option 10 Newton 6 Newton. So first option is the correct one. This is the answer. The question is, it is possible to protect a particle with a given velocity in two possible ways so as to make them pass through a point P at a horizontal distance r from the point of projection. If t1 and t2 are times taken to reach this point in two possible ways, then the product t1 t2 is proportional to. In this question, so the maintain the same horizontal distance with different angles, and for complementary angles only, so maintain the same horizontal distance, means range. Suppose this is the angle of projection 1, angle theta reaches this one, and another angle and also it maintain the same range, that is the same range is given R. For complementary angles, the complementary angles are theta and another one is 90 minus theta, maintain the same range. So for theta 1 the time t1 is equal to, so the time of flight we know the total time is the time of flight, that is 2u sine theta by g. This is t1, theta. Next one t2 is equal to another angle sine 90 minus theta divided by g. So we know 2u sine 90 minus theta is the cos theta, so cos theta by g. But in the question the product of t1 and t2, t1 into t2 is equal to, so t1 is a 2u sine theta by g into 2u cos theta by g. Therefore t1 t2 is equal to, so 2 by g is into, so 2 sin theta u into u square, 2 sin theta cos theta sin 2 theta by g. So u square sin 2 theta by g value is the range. Therefore t1 into t2 is equal to 2 by g into r. Therefore t1 t2 is directly proportional to the r. This is the answer. So second option is the correct one.